Did you know that when you play a first-person game, the way you are seen by yourself and others is a lie? For decades, the video game industry has relied on a brilliant but highly effective illusion to make you feel like you're inhabiting the body of the character. It's an illusion designed to prioritize snappy gameplay, perfect weapon visibility, and smooth camera control. But it comes at a cost. It can be process heavy, and it isn't real. In almost all FPS games, you're essentially playing as a floating pair of disembodied arms attached to a camera lens, which is all well and said in a single-player game. But in multiplayer games, no one wants to see that, so they fake it. When Cloud Imperium Games set out to build Star Citizen, Chris Roberts mandated something that made the game dev team cry a little inside. Among other physics and fidelity choices, one of his goals was to unify the first and third person camera system. While a camera would still exist, there would be no fake arms, no invisible legs, and no rendering tricks or duplicated player models. If you look down, you see your body. If you look in a mirror, you see exactly what other players see when the mirrors work. The camera is literally placed between the eyeballs of your character's skull. But this too came with problems. Vomit-inducing ones, to be honest. Today we're going to deep dive into the technology behind Star Citizen's true unified camera. We'll look at how the games like Cyberpunk 2077 faked their first-person perspective, the technical hurdles CIG had to overcome to make their unified system work, and why this seemingly minor detail, when viewed in the grand scheme of the game, actually gives us good insight into Chris Roberts' vision and the dedication to bring even such a tiny foundational feature to the game in the name of fidelity and realism. But first, to understand why Star Citizen's approach is so crazy, we need to understand the industry standard. In 99% of first-person games, from Call of Duty to Cyberpunk, commonly the illusion is done by the use of two completely different character models, all rendered at the same time. The first of these is the world model, or third-person model. This is the fully animated body that other players or NPCs see running around the world. It casts shadows, it interacts with the environment, and it looks like a normal human. The second is the first-person model, or view model. This is the world from your perspective, usually just a pair of floating arms in the void, maybe some legs or feet rigged directly to the camera itself, with even your weapons being artificially pinned to the bottom right of your screen. Why do they do this? Well, the simplest explanation is to say that true human movement is chaotic. When you walk, your shoulders twist, your spine compresses, your head bobs around, turns and pivots. If a developer strapped a camera to the face of a realistic walking animation, you'd throw up from the motion sickness in 5 minutes or so. And that's exactly what the developers at CIG discovered. However, if you stabilize the camera by separating what players see from what the world sees, developers can give you a perfectly smooth, snappy, esports-ready control, and that's why the lie was made. For a moment, let's take a look at Cyberpunk. CD Projekt Red wanted highly cinematic, visceral, first-person animations. When V reloads a weapon, punches an enemy, or uses mantis blades, it looks incredible to the player. But if you install a third-person camera mod on the PC, the illusion shatters. You see V's spine bending backwards, their arms contorting into horrifying, unnatural angles, and their necks snapping around like some wild beast. The animations were exclusively built to look good in the lens of the camera, ignoring the actual human anatomy. That's why V's shadow often looks bizarre when you swim or run in the game. It's trying to cast a shadow from a broken, distorted first-person rig. Again, this works perfectly for a single-player game, but for a massive multiplayer universe like Star Citizen, that illusion wasn't going to cut it. Star Citizen is built on the concept of ultimate fidelity. There's no room for disembodied floating camera heads. For the immersion to work, you need to feel a part of the world around you, which is even more important now VR has been implemented. CIG recognized early on that rendering two separate models, one for you and one for the universe, just created an unbridgeable disconnect. Not to mention the additional load on servers and clients, which would be fine in match-based games with only a handful of people, but not in an MMO. If you're pointing a gun around a corner, your friend behind you needs to be able to see your body doing exactly that. If you press a button on a ship's dashboard, your character's fingers need to physically touch that button in real space. To do this, the devs took some inspiration from some real-life shenanigans. The dev team, led by Ivo Herzeg, threw out the view model entirely, placing the camera right between the player's eyes. In Star Citizen, there is only one rig, one skeleton, and one set of animations. This removed the need for the illusion at all. As for the camera, press the key to switch to third-person view. The game isn't swapping character models like in traditional games, moving the XYZ location. The camera is simply moving from inside your helmet to a few feet behind you. Your character model is doing the exact same thing at the exact same time, regardless of the viewpoint. This is called the Unified Animation Rig. It ensures complete multiplayer parity. When you're in a fierce firefight at Jumptown or clearing a bunker, the silhouette of the enemy player you're shooting at perfectly aligns with where you're aiming, looking, moving. There are no ghost animations, and so long as the servers are being nice on any given day, what you see is precisely what the servers and other players are seeing as well. But adopting this system opened a Pandora's box. By attaching the player's camera to a physically simulated, motion-captured human skull, CIG ran into a wall of technical nightmares. The immediate problem they faced was the camera itself. Humans possess incredible biological feature known as the vestibulo-ocular reflex. When you run down the street, your brain naturally stabilizes your vision, allowing you to focus on an object even though your body is bouncing up and down. Cameras don't have this. Early iterations of Star Citizen's unified rig were notoriously clunky because the camera was hard mounted to the character's eye bones. Every footstep, every breathing animation, every flinch shook the player's screen. It was a jarring, inaccurate, and headache-inducing nightmare that actually resulted in motion sickness. To fix this, CIG had to build custom technology that the community affectionately dubbed the chicken head system, after the viral video chicken head tracking by Smarter Everyday. Place a link down below for anyone interested in that video. Instead of locking the camera blindly to the skull, they developed a complex stabilization algorithm. This code calculates where the player is looking and actively dampens the transition and rotation of the spine and neck bones. As the character breathes or shifts weight from left to right while running, the camera physically isolates itself from the body's motion, keeping the eyes, or in this case, the camera level. This new technology allows CIG to use hyper-realistic, heavy motion capture data from the body's movement without sacrificing smooth, legible camera controls required for a modern first-person shooter. The second major hurdle was the weapon handling itself. In games like Cyberpunk or Call of Duty, aiming down sights is just an animation trick. The gun model is simply dragged to the center of your screen. In Star Citizen, aiming down sights is a physical, geometric action. The player actually does it. The game uses a system called inverse kinetics, or IK. When you hold the right click to aim, the engine calculates the exact location of your eyeball camera. The character's physical arms then dynamically bend, lift, and align based on joints, the iron sights of the 3D weapon model, perfectly with the camera lens. Because the weapon is a physical object in the world, not a sticker on your screen, it has collision if you walk into a wall. Most normal FPS games, your gun can clip through geometry, through walls, fences, or objects. In Star Citizen, the weapon detects the wall and the IK system forces your character to pull the rifle back to their chest or lower the weapon down. This requires astonishing amounts of real-time math. The system has to blend motion capture data, physical collision, procedural recoil, and the chicken head stabilization all at the exact same time at 60 frames per second, if you're lucky. It's why the gunplay in Star Citizen feels so heavy and distinct. You are manipulating physical mass in a physical space, not just stickers and pictures on a screen. Making the first-person camera is easy. Industry has spent 30 years perfecting the art of the illusion. Cyberpunk delivered incredible narrative experience using those exact tricks, but Star Citizen isn't trying to be an illusion. While feeling tiny in the shadow of the full game, the unified camera rig was one of the hardest, most frustrating technical hurdles Cloud Imperium games ever tackled, right up there with server meshing, persistent entity streaming, and object containers. For years, critics pointed out to the clunky movement and said it couldn't be done, but as the tech matured, the payoff is undeniable. That last statement is indicative of a pattern. When you sit in the co-pilot seat of a Cutlass Black and you look over at your friend, you see them physically moving controls or interacting with the world as their client physically interacts with the world, translated perfectly to your immersively simulated eyes through a crazy process known as the chicken camera. If you enjoyed this deep dive into the tech of Star Citizen, be sure to hit that like button and subscribe. What do you think about the camera system? Are there any other systems you'd like me to cover? Let me know in the comments below, and I'll see you in the next one. Hooroo!